All right, this is the MOSTOOL M8 car jump starter. Really, this is just a very capable USB power station that happens to be able to charge your car battery as well. It has added features like the light here, so that if you need to get under your car hood and see the battery terminals to plug this guy into, there's a nice little flashlight built in there. So the flashlight is great if you're getting under your car hood. You need to see what you're hooking these guys up to. It also has the kind of SOS emergency flashes and then the strobe light flashing to attract attention or just, to warn people, hey, I'm broken down on the side of the road. So as a car battery starter, this guy will charge up a reasonable car-sized battery to get it to be able to turn over your starter. I don't really believe it can produce 6,000 amps. I don't know if this guy's going to produce enough power all by itself to be able to turn your starter motor. I think the key thing here is it's to top up your battery, to charge your battery back up to get the starter going. Now, just as a USB power bank, this thing is very capable. So it has 3 different USB out ports, and there's a black USB-A port, which just does 5 volts at 3 amps. There's a blue USB-A port, and that guy's quick charge compatible, so it can do 5 volts like normal, but it can also negotiate up to 9 volts or 12 volts to power some higher, power devices or charge faster. And then there's the USB-C power delivery port, and that guy will charge this at 60 watts or it'll export 60 watts. So this guy can power up pretty much all your USB-C power delivery laptops, tablets, anything like that. In addition, there's a 12-volt output port that has a barrel connector. They don't include a cable for that, but if you have a pretty standard 5.5 millimeter outside, 2.5 millimeter inside tip positive barrel connector, you plug that in and you can export the actual battery voltage, which ranges between 12 and 16 volts. So that's a very good, replacement for a 12-volt battery to power something. I've tested the capabilities of the battery here. I believe their capacity rating here, the 88 watt-hour capacity rating, I believe that it can deliver 70-some going through the conversion circuitry here, and it takes about 96 watt-hours to charge it back up. So all the ratings on the back here are accurate with potentially that 6,000 amp. I mean, it's 8-gauge cable here, which is pretty decent size, but if it's doing 6,000 amps, it is for a microsecond. So it is, it's going to be a decent battery charger to get you up and going on the road. If you run your battery down with a light on or something, this guy will charge it back up enough to get your car started. But I don't think it would be able to start your car without a battery in the car. This is a MOSTOOL M8 jump starter. So I was sent this to review for free. MSRP on it looks to be like $160, $170, but I've seen it for sale with a 50% off coupon, so it looks like street price might be closer to $85. So it comes with a jump starter, the zippered carry case, USB to USB-C cable, a user's manual, a charging cable, and a jumper cable. So let's take a look at those items. Alright, so we have a semi-rigid carry case with a little handle and zippered clamshell opening here. And we have lots of accessories. So this is a battery-based jump starter. And these cables look to be relatively heavy duty. Its label is 8 AWG. Pretty serious looking plug there. It has a relatively thick instruction book. It looks like it's so thick because it has multiple languages in it. We have English, German, Italian, Spanish, and French. We have 2 little cables here. There's a USB-C to C, a USB-A to C, and we have a card, and then this is the main unit itself, and it's sitting in a little foam cutout, I guess, that makes it more closely fit this case so it won't rattle around inside the case. All right, so it looks like it has a light, which is always useful if you're jumping your car. There's the main jump starter port on that side over there. And then on this side, there's a rubber cover that has multiple ports here. So we have a USB-A out. It looks like another different USB-A out, an in-out port, a USB-C, and then there's a DC, looks like a 12-volt type of DC style barrel connector out. And on the back here are some information and tips. So to jump start your car, you connect the clamps. It should say ready. Start the vehicle engine and remove the clamps. So they have tips and warnings, 1, 2, 3, 4. Do not start any engines that exceed the maximum displacement the jump starter can bear. It also has some specifications where it says the capacity is 88.8 watt hours, the voltage is 12 volts. On the USB-C port, the in-out port, it does 5, 9, 12, 15, or 20 volts at 3 amps max. So everything is 3 amps, so its power delivery 60 watts, which is pretty reasonable for a power bank. And then it has output 1 and 2, 5 volt, 9 volt, and 12 volt. So I think the blue USB-A port here is probably the one that does multiple voltages, and the black USB-A port is the one that does just 5 volts. And then it has a DC output here, which I believe is connected directly to lithium-ion cells because it has a voltage between 12 and 16.8 volts at 10 amps. So it does not have a cable for this little barrel connector. I kind of suspect it might be a 5.5 millimeter external and a 2.5 internal, kind of very standard 12 volt barrel connector, but I'll have to check that. All right, I've plugged into the first black USB port, and at the 3 amp draw, the voltage is sagging a little bit to 4.8 volts, but I'd still say, you know, it's basically doing 3 amps at basically 5 volts there. Now, if you want this to not sag at all, it looks like at about the 2 amp rate, you know, this is 4.94 volts, so it does sag a little bit when you get up the extra amp draw there, but I'd say it puts out, you know, 15 watts. Now I've plugged it into the second USB port, that's the blue USB-A port, and here I'm doing 5 volts and it's not sagging at all at 3 amps, so I'm getting, you know, 4.98 volts at 3 amps. Alright, so the black port looks like it can basically do 5 volts. It supports Apple BC 1.2 5 volt levels, but none of the fast charging higher voltage levels. Now the second blue USB-A port does look like it supports some 9 volt levels. There's Quick Charge 2.0, Quick Charge 3.0. It'll go for 5 volts, 9 volts, 12 volts. It also looks like it supports Samsung AFC at 9 volts and Highway FCP at 5 volts and 9 volts. Now the USB-C port is where this guy really supports everything. It does power delivery, it says up to 65 watts, power delivery 3.0, Quick Charge 2, Quick Charge 3, Huawei, Samsung, BC 1.2, you know, so it supports a lot of the protocols on that USB-C port. And so basically anything that does power delivery over USB-C is going to work with this guy. Okay, I have my laptop charging at 20 volts on the USB-C port. I have this quick charge device going at 9 volts out of the blue USB-A port. We're going to plug in another USB load. This is a 5 volt load. And yes, this guy here is running 3 amps at 5 volts. Out of the USB-A port on the top. So we're able to get 5 volts out of the dedicated just USB port. The USB-A port with the blue color that does quick charge is going at 9 volts, and my laptop is over here charging at 20. So we're able to get 3 separate voltages out of the 3 different ports. If you plug this into a USB-C power delivery cord, it indicates it's charging by saying in, the second digit is flashing, and we have this lightning bolt indicator, or 2 lightning bolt indicators. Alright, so I have this going through the meter. It is negotiated up to the 20 volt level. It's charging at about 2.8. Well, I saw it hit a 3 for just a second there. So it's getting very close to the 3 amps, 20 volts claim. So we're getting 59, 57 watts in. So it's basically charging at the 60 watt level here. So after it's been charging for a while, it's still going at basically 60 watts, but the percentage display that flashes is gone. We do have the in light showing here. If I push this power button, it brings up the rest of the display, and now we're at 88%. So it does kind of quiet down a bit while it's charging, and if you want to see all the numbers, you have to push the power button. So given that this guy can do power delivery at 60 watts in, it does not surprise me at all that it can, rapidly charge my power delivery phone. It also has no problem powering my laptop. Now the package comes with a provided USB-A to C charging cable that I'm using here. And I have this plugged into a quick charge 3 capable charger. And it's negotiated up to the 9 volt level at 2 amps, so it's charging at just a little under 20 watts here, so it's doing 17.7 watts. So if you plug it into a USB-A port that can move a voltage up to like 9 volts, it'll charge a little faster than like the 15 watts you might get out of a 3 amp port. Now it also comes with this USB-C to C cable, and if you plug that into a capable USB-C charger with power delivery, it'll negotiate up to 19 volts. It's doing 2.9 amps here, and so it's getting 58 watts. So ideally, you probably want to be charging this guy from a USB-C port, power delivery preferred. And if it's a 60 watt power delivery charger or higher, that's great. You'll get full charging speed. They do not provide a barrel connector cable. This is one I had on my own. This is a 5.5 outside, 2.5 inside. It's a pretty common size used for 12 volt circuits. I've plugged it in there. And so what I've found is that this barrel connector is not directly connected to the battery. It's connected via electronics. So if this guy's not turned on, there's no voltage on that. If I push the button to turn it on, it says out, and now we're getting 16.36 volts, which I think is probably the actual native battery voltage in there, but it's going through some type of a solid state switch to turn it on and off. The interesting thing is that when I'm charging this guy up with a USB port, it's not the battery voltage, but it's closer to 5 volts. So right now I'm charging this guy with a USB-C port, and it has 20 volts coming into the battery. But the cable coming out of this guy is at 4.6 volts, so it's like a 5 volt USB output at that case. So I don't believe you can necessarily charge it in via this port. The manual doesn't say anything about charging in with this port. It does not include a car cigarette lighter adapter. So I think you should use this as a 12 volt out port. But keep in mind, it won't be providing 12 volt outs while the battery is being charged. It only does that when this guy is in output mode. And so when I unplug that, hit this to output mode, at that point you'll get somewhere between 12 and 16 or 17 volts coming out of this guy. And I think the higher end of the voltage range is when it's fully charged, and when it gets to low charge, it's probably closer to 12 volts. The manual does say this guy is good for 10 amps. So 10 amps at 12 volts is more watts than the USB-C port puts out, but I think it's a little bit unregulated. But if you have a 12 volt load where you need a decent sized battery, you could make use of this as a kind of a 12 to 16 volt automotive battery replacement for anything that needs about a 12 volt input. So this guy claims to have an 88 watt hour capacity, and given the size and weight of it, I think it certainly could have 88 watt hours worth of lithium ion batteries in here. So to test that, we are going to charge it all the way up until it stops accepting current, and then I'm going to discharge it just with a 15 watt load, and we'll go through the meter and basically keep account of how many watt hours come out of it. Now, while this guy is charging via the USB-C port, I have not been able to get the light to turn on, so you can't use it as a lantern or light while charging it. I kind of suspect you also will not be able to use it as a jump starter while it's in charging mode. So this included USB-C to C cable was able to push 3 amps at 20 volts or 60 watts, and so this cable is definitely able to keep up with the power bank in both directions. Now I've seen this included USB A to C cable do up to 20 watts depending on if you have a quick charge capable output. And so I suspect this cable would be just fine for plugging any device into the USB A ports of this power bank. And in a pinch you can charge off of any USB A port, although obviously USB-C power delivery is going to charge faster. Alright, this guy says it's almost done charging, and if you look at the voltage, it's still at 20 volts, but the amp draws down to half an amp, and so it's only drawing about 7 to 10 watts right now, so it is definitely tapering off, starting to kind of trickle charge the last little bit of the battery. Alright, this guy's done charging. It's still taking about 0.6, 0.7 watts just sitting here. If you turn the screen on, it says 100%, it's not flashing anymore. This guy goes up to about 2 watts just to, run the screen and the electronics inside of it. But basically, it is fully charged. Okay, I have my little 3 amp 5 volt load running around here. We're drawing about 15.5 watts. So overnight I'm going to discharge this guy. The meter will keep account of how many watt hours it can deliver. Now that is going out through the voltage conversion circuitry for the USB ports, and so that will be a lower bound on the battery capacity. Right, overnight this guy has gotten down to 0% and it is refusing to supply power out the USB ports. Looking at the meter, it supplied 73 watt hours before it shut down, and that's pretty consistent with an 88 watt hour raw battery that is converting to 5 volts through the efficiency losses. Now I'm going to charge it back up. We will reset this meter and determine exactly how many watt hours it takes to charge it back up, and I would expect that to be a little more than 88 watt hours. Alright, so even from 0, it is charging at pretty much the 60 watt rate here. So this guy's been charging for an hour. It has 60 watt hours in it right now because it's charging at the 60 watt hour rate. And temperature wise, it's barely warm to the touch. You can see here there's some what looks like probably the charging electronics right up there. And other than that, there's some slight warmth here. I'm actually leaving more warmth on it. When I put my fingers on it, my fingers warm up the case more than the case has been warmed up. So it looks like there's plenty of capacity inside to absorb 60 watts continuously with really not a whole bunch of heat being built up here. So there doesn't appear to be any problem whatsoever at putting power in or out of this guy at 60 watts. Okay, this guy is drawing less than half a watt. It's done charging. It says 100% charged here. And it took 96 watt hours to charge this guy up. And so that sounds very reasonable for having an 88 watt hour battery inside of it. So I do believe the claims here are in the nameplate of the battery capacity. Alright, I have a motorcycle battery here that definitely needs a jump start. It's at like 10.8 volts, which is pretty low for a 12 volt battery. So we are going to plug this guy in here, and there is a kind of square D side and a round side, and there's some places here where you'll definitely only be able to plug this in the correct orientation. After my first jump charging attempt, it went from 10.8 to 11 volts because it put a little current into it. We're going to turn this guy on. It says, hey, it's 11 volts. It's going to click on and start charging it. And the battery voltage jumped up really fast because it's just measuring it at the terminals here. And with this small little battery, this guy's able to pop it up to 16 volts. You see the voltmeter says 16 volts. So it says, okay, your car is ready to jump start. Try starting the engine on right now. And you can hear in there's a clicking noise where it will disconnect the internal battery every so often and check the voltage, and you can see here it flips back down. It says, oh, it was at 12.5, and then it clicks back on, and it says, okay, I'm putting out 16.5. So it is ready for a car to be turned over at this point. Now let's test out their reverse polarity protection. So I am deliberately putting this on in incorrect order, so I have the positive to the negative terminal and vice versa. Okay, we have the error message here. It's basically saying, hey, something's not right, you have this thing connected incorrectly. I tested this once before, but I have it directly short-circuited here. All right, pushed and held the jump button, it turned off. Pushing the jump button again. Just going to turn the button on. Okay, now it's giving me an error message. I'm a little uncertain as to when you push the power button and when you push the jump button, but by pushing both buttons, it seems to do the right thing. At some point it turns on and starts trying to put power into the battery. Okay, I have my voltmeter attached to the battery clamps here, so there's no battery attached to this guy. So I'm going to turn it on. It goes and it goes up to like 1.4 volts. So I think what it's doing there is it's kind of probing for a battery. It says, hey, are you going to accept any current here? Maybe checking internal resistance, something like that on the battery. It's not, trying to charge the battery there. So I'm going to push and hold the jump button, and we'll see if this jumps up to a higher voltage. Now it's changed. It's gone slightly negative here. Now it says ready, and it's 1.4 volts. Nope, there, it hit 16.53. So yeah, it looks like the jump button here will jump start it and basically force it to start charging the battery, even if it's not entirely certain, that the battery's correct. So the manual calls the jump button the force start button, and it basically says, connect this to your battery. If the display shows the car battery voltage and ready, start your car. Otherwise, you have to long press the jump button until ready light turns green and then start your car. So apparently in some cases it won't auto start. This might be if it can't detect the battery voltage at all, you need to press and hold the jump button for it to initially start charging the battery. So if your battery's like down at 0 and it can't detect the voltage at all, that might be a way to bypass the incorrect polarity or not detecting a battery type safeties. Alright, so I have this guy turned off, it's hooked to the battery, I pushed the on-off button, battery voltage 10.9, and now it is putting in 16.5 volts to the battery. And because this guy probably has at least as much or more capacity than that little lead-acid battery, because lithium-ion cells have more energy density, it's basically able to bring the terminal voltage up to 16.5 almost instantly. If you had a big car battery here, that wouldn't go that quickly. It would basically be charging it up, and it would wait until the voltage got high enough, and only then would it pop up this big green ready. And when you see the ready, that's when you go try to start your car. Okay, so I've been pretty impressed with this guy. It meets the specifications for all of the USB in and out power. The capacity, I believe, is an 88 watt-hour battery inside. It is safe in that I've tested the direct short circuit, putting it on the battery backwards. And it detects those error conditions and refuses to connect a reverse battery to this battery. It is charging the battery up, and so if you have a battery that just ran down because you left the lights on or something, I believe this guy is going to get it back to the point where you can start the car. It might take a little while because it's going to charge it up. I don't really think it's putting out 6,000 amps at any peak point ever. So I really don't believe that. I don't have a battery amp tester to test that with that goes that high, but just 8 AWG wire and these little clips, I don't think they're going to do that. This guy charges up your battery so that then you can start the car. It will provide some power to the starter engine, the starter electric motor itself. And so if your car is only needing a battery top up to get started, this will probably do it. Now, if you're having a problem where you ran your battery down because your car wasn't turning over, I don't think this is going to fix that situation. Maybe another vehicle with, full jumper cords with the engine running would be able to deliver enough current to, run your starter for a long time to eventually make your engine start up. But this is really, I think, if you have a problem where your battery's been drained or ran down, you need to top it back up, get your car started, and there's not another other situation that's keeping your car from turning over easily. I think this will do a good job of jump starting you there. I also like the fact that it has the added features. It has the flashlight, so you're under your hood at night and you need to figure out where to clamp this thing on. Having that light right there is going to be very nice. The SOS and the flashing strobe lights might be good as a roadside emergency signal. Also, I think this is really, in addition to being a jump starter, even if you threw these guys out, just using this guy as a power bank, you know, you have your in-out at, you know, I saw 60 watts in and out there. And so, you know, USB-C power bank, this guy will run a laptop for quite a while, and you can run some other devices as well out of the 2 USB-A ports. And there's also this 12-volt barrel connector. So potentially for, you know, astronomers looking to run a telescope, a dew heater, something like that, that's a very capable little 12-volt output there, 10 amps.